So in the previous class, we also didn't do any practice on nomenclature, right? We had only one question.
In the last class, yeah, we did some questions. We did this.
We did some question.
No, I mean we. Yeah, I guess
this question.
you just gave some. This.
I'm going to give you just match it. I'm going to give you write the IUPAC of following. Which in the first stage K3 CR C2O4 whole thrice. Then I'm going to give you another one, that is CO Cl2En whole twice Cl. Then the third one I'm going to give you is CO NH3 whole twice whole 5. It's whole 5. Then comes CO3 and Cl. Do let me know when you are done with. So let me know that. Nafisa, will you be able to solve it?
Yes, sir. Trying.
Okay.
So the first one is potassium. Potassium. Chrome.
Yes, next. Potassium. You did the write the correctly potassium. After this, you need to write the name of the ligand. Only one ligand is there. What is the name of the ligand?
Trioxalato.
Trioxalate it is, but since it is a anionic ligand, so the name ends with O. So it becomes trioxalato. Now, before writing the name of the central metal atom, look at this. No negative charge, but there is positive counter ion. If you are going to remove it, there will be negative charge. So its name will be ending with 8. So it will be chromate. And what will be the oxidation state of this chromium?
3.
3. Very good. So it's correct. Can you tell me about this? Do let me know if you are unable to do it, then I'll explain.
Sir, can you explain?
Okay, so there is no positive counter ion, so directly we will jump to the this ligands, and as you know that this is ethane 1,2 diamine and this is chlorido. Since chloride is an anionic ligand, so it's named with O, and in alphabet it comes first. So I'm going to write dichlorido. After this ligand is complex ligand, so instead of using di-tri-tetra, we will use bis-tris tetra case. So I'm going to use bis and then bracket ethane 1,2 diamine. Ethane 1,2 diamine. Close the bracket. Move to the after ending with the name of the ligands, come to the central metal atom, which is cobalt, because there is no negative charge, and if you are going to remove this negative, there will be positive charge. So the name of the central metal atom will be as it is, cobalt. Then writing the oxidation state, so you can see the oxidation state again will be here 3, and just give some space and then write chloride. Is that clear?
Yes, sir.
Okay, now come to this next. Can you do the next one?
Sir, if it's 5, what would be the name? Like
Penta,
trisamine, oh yeah, okay.
pentamine. See,
Pentamine.
it's pentamine. Can you tell me the name of this ligand? CO3. CO3 is basically carbonate and it has negative -2 charge, so it's named with carbonato. And if you look at the square bracket, there is no negative charge, and if you are going to remove this, there will be positive charge. So the name of the central metal atom will be as it is. So it will be cobalt. And if you are going to calculate the oxidation state, will be again 3, and then chloride.
Yes, sir.
Okay, so this is how we write the IUPAC of the different complex compound. You should practice from NCERT too. Now I'm going to start another topic, that is isomerism. And you know, isomerism is basically same chemical formula having different arrangement of ligands, that is called isomerism. Okay, isomers, and the basically phenomena or the process is known as isomerism. Okay.
Yes, sir.
So I'm going to change, show a slide, share a slide. You will be able to see it now, right?
Yes, sir.
Okay, so you can see, as you can see, what is isomerism. So basically isomerism having same chemical formula but different arrangement of atoms, due to which they differ in one or more physical properties, that are called isomers, and the phenomena is known as isomerism. So please do write it, and there is a categorization of this isomerism in two parts, structural and stereoisomerism. Further, this structural isomerism is divided into 4 parts, and this stereoisomerism divided into 2 parts. So please do write it and let me know, so that I will change the slide and explain the rest of it. Let me know when you're done with this.
Yes, sir.
Yeah, waiting.
Yes, sir. Done.
Okay. So as you can see, this isomerism is of two types, that is a stereo and a structural isomerism, and they are further divided into four parts. A structural isomerism divided into four parts, and then a stereo isomerism divided into three parts. So please do write it.
Yes, sir. Done.
Very good. Now see, what is this? Basically, solvent isomerism, ionization isomerism, linkage isomerism, they are very easy. So as you can see that solvent isomerism, basically there will be exchange of solvent, that means also known as hydrate isomerism. There will be exchange of H2O and Cl. Just wait a minute, it's abruptly closed sometimes. So basically what I was saying, Nafisa, there will be exchange between counter ions and ligands, and you can see if the exchange between water and other will take place, then it will be known as then it will be known as hydrate isomerism. Hydrate isomerism is also basically ionization isomerism is similar to that hydrate isomerism. That hydrate isomerism. Just wait a minute, please. No, let me change this slide. Can you see the screen? Nafisa? Nafisa, are you there?
Yes, sir.
So basically, what is this solvent isomerism? So it is also and basically isomerism is different in number of water molecule as ligands and free solvent molecule in crystal lattice. So as you can see, there is H2O, 5 H2O as a ligand, and say 1 Cl as a ligand, and Cl2 and H2 as a what we say counter ion. Now there will be exchange between this Cl and H2O, and it becomes H2O whole 6. So this is what solvent isomerism is. So basically there will be exchange between H2 and one of the counter ion, that is called solvent isomerism. Is that clear? Same chemical formula but different
Yes, sir.
properties, physical properties. Please do write. Let me know when you're done with this.
Yes, sir.
Now, isomerism and hydroisomerism is almost same. Only the difference is that if you are going to exchange with water, it is solvent or hydroisomerism. And if you are going to exchange with other than water, as you can see in this SO4 and Br. So if the exchange between these species will take place other than water, that is known as ionization isomerism. So I think it's easy, right? You have to write a lot because I had written already. These are some theoretical part which is quite easy. Just let me know if you don't understand or
Yes, sir. Done.
very. Now there is coordinate isomerism. There will be coordination between two coordination compound and there will be exchange of ligand between these two. So as you can see, this is your coordination compound or complex compound. And now this type of isomerism is due to exchange of ligands in between cationic and anionic coordination sphere. If there is complex compound which is cationic and anionic, so there will be exchange of ligands. So as you can see in the first place, chromium has the ligand NH3, and in the second, which is anionic complex, which is cobalt having CN. Now there will be coordinate exchange, or you can see the ligand is switched to cationic and anionic and cationic ligand, anionic and cationic coordination sphere. So this type of isomerism is known as coordination isomerism. Wait a minute, please. Nafisa, are you done with
Yes,
this?
sir. Done.
Nafisa, as you can see, this is quite easy. Now the fourth, which is linkage isomerism, and it is totally related to ambident ligands. So basically, in this case, central metal atom or ion have different linkage with ambident ligands. Both have same chemical formula, but in this, you can see cobalt is connected with ambident and ambident ligand, with nitrogen. If it is written like this, it is connected with nitrogen, and this is connected with O. Only the linkage between central metal atom and ambident ambident ligand is changed. So please do write it. Let me know when you are done with this.
Yes, sir.
So this is the type of basically structural isomerism. Do you have any doubt regarding this structural isomerism?
No, sir.
Okay. Now see in the next, that is geometrical isomerism, and it is a part of basically it is a part of stereoisomerism. So basically geometrical isomerism only occur in this heterolaptic complexes. As you already know what is heterolaptic complexes. Complexes having different ligands or more than one type of ligand in a complex, that is known as geometrical ligands, and it is of two types. You can say cis or trans. Cis or trans. If the group is on the same side, then it is cis, and in opposite side, then it is trans. You have studied this in class 11th organic chemistry. Do you remember?
Yes, sir.
Okay. So first of all, you need to remember these points that I had already told you. If coordination number of any complex is 4, that means its hybridization is sp3. If coordination number is 4, it can be DsP2 also, that we will study how this hybridization differ from each other, even having the same coordination number 4, 4. We will study after this topic. And if the coordination number is 5, then it is sp3d. And you have to also remember this, if it is sp3, that means tetrahedral dsp2, square planar sp3d, trigonal planar. If the coordination number is 6, it can be either sp3d2 or it can be either d2sp3, and its geometry is octahedral and octahedral. Both will have octahedral geometry. So please do write this, then we will go for this.
Yes, you're done.
Very good. Now see, we need to study about this geometrical isomerism only these two. A square planar, only about these two. Wait a minute, it's hanging. Can you see the screen? Again,
Sir, geometrical isomerism, right? Yeah, I can see.
yeah. Wait a minute, wait a minute. Can you see the screen now?
Yes, sir.
Geometrical, okay. So only we have to study about this square planar and this octahedral in this what we call geometrical isomerism. Now, see, if we have a square planar which have a complex formula of ml2x2, what does this means? ml2x2. As you can see, this ml2x2, and it is a square planar, that means coordination number equals to 4. All these 4 ligands are unidented. So this is the complex compound. If both group on the same side, that means it is cis. If both group on the opposite side, it is trans, right? It's very easy.
Sir, I can't see the next. Okay, yeah, I can see.
You can see the next, like this is the first one.
Yes, sir, yeah.
Let me know if you're done.
Yes, sir, done.
Very good. Now we are going to take cases like if both the ligands are same. Now we have a formula like mx2ab. That means one of the ligand is same and another is different. So we will go with this. So they are on the same side. We will see with respect to this. So they are on the same side. That means is they are on opposite side. That means trans. Okay. Please do write it.
Yes, sir.
If you know cis and trans from class 11th, it is quite easy, and if you still have any doubt in this, you can ask me again. Let me know when you're done with this.
Yes, sir. Done.
Very good. Now the last and all the cases we have done. Now the last case is that if all the ligands are different, if all the ligands are different, as you can see, I'm just erasing it. Wait a minute, please. It's very easy. Do you know what is PY? PY is pyridine. It is also acting as a ligand. So you can see if all the ligands are different. So what will happen? How you are going to tell me what is the number of isomerism that it is forming? So you are going to keep one of the ligand constant and rotate all these three. So this is NH3, NH3 here also, NH3 here also, and now you are going to rotate it. PY on the here, and now you rotate it in and make it here. So there will be possible three isomerism in this step in this type of cases. Are you getting my point? If it is a square planar having four different ligands, it will have three isomers. Okay, isomers.
Yes, sir.
Please do write it. Let me know when you are done. Let me know when you are done with this. No, please.
Yes, sir. Yes,
Now
sir.
the next is very good. Next is basically PY is pyridine. Now the next is basically your square planar having bidentate ligand. You already know what is bidentate, having two donor site in a single ligand or single this. So as you can see, this is symmetrical, this bidentate. bidentate ligands. So this is the bidentate PT, and this is the symmetrical ligand. Asymmetrical ligand, it should be asymmetrical, not symmetrical, because both will have same group, so you cannot differentiate it. So you can see NH2 CH2 NH2 CH2 on the same side, that's why it is cis. And in this case NH2 CH2 NH2 CH2 on the opposite side, that's why it is trans, right? Are you getting my point, Nafisa?
Yes, sir.
Okay, please do that.
Yes, sir.
Very good. Now the cases of this square planar is completed here. Now we will go for octahedral. So as you can see, we are starting from this unidentate ML2X4 octahedral. That means coordination number is 6. Coordination number is 6, and this is the formula in which you can see coordination number is 6. That means octahedral complex, and also you can see if these two group on the same side, that means cis, and if these two group on the opposite side, that means trans. Okay,
Yes, sir.
please do write it. Wait a minute, please. तो रहिए सर. Nafisa, are you done with this?
Yes.
Okay. Okay. Now see the next possible is this in octahedral complexes of formula this mx2 and L. So as you can see, this L, sometimes it's not working. So as you can see, one of the ligand is bidentate, that means, and it is twice, that means 4 coordination comes from there. And this is the unidentate. So it will be, this is the formula. So with respect to any one of them, as you can see, this will be on the same side, that's why cis, and this will be, or you can either consider this part also, they are on the opposite side. So that is why it is trans. Okay.
Yes, sir.
Please do write it and then let me know. Mm. Now, are you done with this?
Yes, sir.
Okay. So this is the first type. Then comes to the second, which is in octahedral complexes in which Ma3B3 all are the single unidentate ligands. So basically, there are of two types. The one is facial, or the another is meridional isomerism. How you are going to recognize if they are facial or meridional? So basically, if three donor atoms, this is three donor atoms of same ligand occupied the adjacent position, they are basically simultaneously. If they are like this, you can see if they are in this position simultaneously. Wait a minute. If they are on the same position simultaneously like this, then they form facial arrangement, facial isomerism or face isomerism, we call it. Or if they occupy the meridian, that means in between these three, you can see any one of these three which are same. And if you got any other in between these three, so that is mer isomerism or meridional isomerism. So please do write this point and then I will show you the example. Then I'll again explain. Let me know when you are done with this.
Yes, sir, done.
Okay, so have you draw the structure? So
No,
this is
sir.
what you can see. So if they are simultaneously like this, so there will be what we call phase isomerism, and this will be mer isomerism. Okay, mer isomerism. So please to write this structure. Then we will go to VBT, which is valence bond theory.
Yes, sir, done.
Now, Nafisa, come to the next slide, which is VBT. So, Nafisa, do you know what is how to do electronic configuration? You know that, right? Can you see the screen?
Yes, sir.
So, this is your valence bond theory. Now, uh, right, the first I want to ask some basic questions. Write the electronic configuration of wall. Write the electronic configuration of following. The first one is copper, then Cu plus 2, then chromium plus 2. Also, I want you to write cobalt plus 3. Do you know the atomic number of all this? It is 29, it is 24, it is 27. So can you do the electronic configuration of all this? Can you do the electronic configuration?
I'll try. Sir, can you explain how to do?
So you don't know how to do electronic configuration. See, if you have sodium and you need to do the electronic configuration. So this is 1s2 2s2 2p6 3s1. Should I need to explain from the basic how to do electronic configuration?
Yes.
Oh. So see, so you can see, first of all, this is in NCERT, it is already given. So please do write it. For inorganic chemistry. It's very important to know the electronic configuration. So 1s, I'm going to write 2s 2p, then 3s 3p 3d, then comes 4s 4p 4d 4f, then comes 5s 5p 5d 5f, then comes 6s 6p. It is enough, I think. 6d 6f. Now see how we are. Do you know at least do? I think you know. In S, maximum 2 electrons will go. Yes or no? In P, maximum
Yes.
6 electrons will go. And in D, how many electrons will go? And F, can you tell me? In D, how many maximum electrons can accommodate?
8.
10. There is 4 difference. And in this 14 electrons. Okay.
Yes, sir.
So see, first it will go in S. That means 2 electron you will give here. Then come back. That means you are going to take a U-turn. And then again you are going to pass through 2s. If you still have 2 electron, you have to donate it or accommodate in this orbital. Then you are again going to take a U-turn and then go like this. If you still have any electron, you are going to accommodate in this orbitals, and then you are again going to take U-turn and then again going through 3p and 4s. Then again going to take U-turn, and then are you getting my point? If you have electron, you are
Yes.
going to fill it in this order. Again you are going to take U-turn and then again going like this and again. So you will go in this way and you need to take U-turn. That is very important. You cannot fill in any order. This is based on above principle. This is 5p. You have to take U. Just write it and then let me know. Have you got it, Nafisa?
Yes, sir. I put it.
Please do write it and then let me know.
Yes, sir.
Very good. Now see how you are going to do it. If you have copper and you need to do electronic configuration and its atomic number is 29, that means you have 29 electrons that you need to accommodate. Okay. So first you
Yes,
are
sir.
going to fill with this. So 1s and you need to have 2 electron in this, right?
Yes.
No, wait a minute. You don't exactly know how to do electronic configuration. So we are going to start from very basic. So hydrogen has atomic number 1, right? So it has one
Yes.
electron. If its atomic number is 1, that means it has 1 electron. So you are going to give it 1 electron to this. This is the electronic configuration of hydrogen. You don't need to write 1s2 because hydrogen has only 1 electron. That's it. That's why it is 1s1. Now helium, after hydrogen, it is helium and its atomic number is 2. That means it is having 2 electrons. So it will have M1s2. Then after helium, it's lithium. It has 3 electron, 1s2. It is filled. Now you are going to fill the 2s. So 2s1. Lithium after it beryllium. 4 electrons is there, 1s2, 2s2. Then it comes boron. So 1s2, 2s2, and it is filled. So you will move to the next orbital, which is 2p. 1. Carbon, which has 6. So it is 1s2, 2s2, 2p, 2. Because P will have efficiency to take 6 electron. So if you are going to do the configuration of nitrogen, which is having 7, 1s2, 2s2, 4 electrons gone, then 2p3, 7 electrons. After this oxygen, you can see 1s2, 2s2, 2p4. Now then fluorine comes. Now you can see 1s2, 2s2, 4 electron goes, then 2p5. All the 9 electrons are accommodated. Now neon, as you can see with neon 1s2, 2s2, 2p6. All the electrons are filled in this orbitals. Now sodium, if you are going to do the electronic configuration of sodium, 1s2, 2s2, 2p6. Still you have 1 electron left. You cannot fill in this because it's on maximum quota or maximum capacity. Then after 2p, you need to move to the 3s. So it will have 1 electron. Are you getting my point?
Yes, sir.
Please do write it. Then I will give you some more to do by yourself. Let me know when you're done with this.
Yes, sir.
Are you done with this?
Yes, sir.
Okay. So I have done it till sodium. Now you are going to do for magnesium, then aluminum, then silicon, then phosphorus, sulfur, chlorine, argon. Its atomic number is 12, then 13, then 14, then 15, then 16, then 17, then 18. After argon, it is potassium, which has atomic number 19, and then calcium, which has atomic number. Please do it.
Sir, for number 1, magnesium is 1s2,
Just do all this
2s2.
and then
Okay.
then we will match. Okay.
Okay.
Please do it. Just let me know when you are finished with this.
Okay, sir.
Let me know when you are done with this.
Yes, sir. So
Okay. Are you done up to this?
yes,
Let
sir.
me write and just match it. 1:2, 2:2, 2:6, 3:2. Have you done it correctly?
Yes, sir.
What about this?
Yes, sir.
Very good.
2s2, 2p6, 3s2, 3p2.
Very good.
Yes, sir. 1s2,
It will be
2s.
same like this, and
Yes,
then 3p,
3p3.
right?
Yeah, yeah. Yes, sir.
And
Yeah.
then 3p4, and then
Yeah, yes,
comes
sir.
3p5,
3p5. Yeah. And
and then
3p6.
3p6. And after this, you can
Yes.
see after 3p6, you will have 4s1, right?
Yeah,
And
4s1. Yeah,
after
4s2.
3p6, it will be 4s2, right?
Yes, sir.
Now, can you do the electronic configuration of Na plus? As you can see, there is plus one charge. That means one electron is removed. Yes or no? Now you have 10 electrons. So you are going to do the electronic configuration according to this electron, 10 electrons, 1s2, 2 electrons accommodated, 2s2, 4 electrons accommodated, 2p6, all the 10 electrons accommodated. So the electronic configuration of Na plus is this. Is that clear?
Yes, sir. Okay.
Now do the electronic configuration of Cl minus. Cl minus means what? It gains one electrons. It has atomic number at 17, but now it has
Yes,
18
sir.
electrons.
18.
So please do it.
Sir, it will be
Yeah. It is 1s2,
1s2, 2s2,
2s2,
2p6,
2p6.
and
All the
then
10
after
electrons
that,
are here. Now,
yes,
after
sir.
this, 3s2, 3p6, right?
3s2, 3p6. Yep. Yes, sir.
Very good, very good. Now, can you do the electronic configuration of Mg plus 2?
Yes, sir.
Please do.
Sir, the answer will be
Yes.
1s2, 2s2, 2p6, 3s1.
Oh, 3s1. Can you
No,
tell
no,
me
no,
the atomic number?
no, 2. That's it. Because we,
It
yeah,
has
we
10
just
electrons.
minus 2. Yeah, it's only 10. Yeah. No
Very
need 3.
Now, very good. Now, from you are going to do this scandium 21. This is for homo, titanium, vanadium, chromium. Then comes your manganese. Then comes your manganese. After manganese, you are having iron. After iron, you are having cobalt, then nickel, then copper, and then it's your zinc. These are all homework along with this. Pu plus, Pu plus 2. I have written all the atomic number here. So you can go for this
Yes, sir.
chromium plus 2, chromium plus 3, Fe plus 3, as well as Fe plus 2, nickel plus 2, cobalt plus 3. These are all you need to do. And also the atomic number of Kz, which is 47, and Ag plus as well. So please do write the electronic configuration of all this and send it to me. Please, I want to see. Okay.
Sir, now?
No, not now, but today or tomorrow. By tomorrow, you need to send it.
Yes, sir. Okay. Because maybe tomorrow,
Please do
because
that.
I have to study for physics exam.
No problem. Tomorrow or day after tomorrow, you